In this video, we are going to see example on convolution integral using graphical method. For this, we are considering x of t as input signal, which is equal to u of t, and the impulse response of system is given as h of t equal to u of t. Now, we will first of all write the equation for convolution integral, which is given as y of t equal to x of t convolving with h of t, and it is equal to integration minus infinity to plus infinity x of tau into h of t minus tau d tau. So here we are supposed to find out the signal x of tau and h of t minus tau, which is folded and shifted version of the impulse response, and then we are going to multiply it with the input signal x of tau to obtain desired output y of t. To obtain y of t, we are going to use graphical method, which has fixed steps that we are going to follow to obtain the desired output y of t. So let us begin with step number 1. Here we are supposed to find out x of tau. So we are going to draw x of tau signal. So for this, I will be drawing an axis, and we are going to draw all the signals one below the other. The first signal is x of tau. So this axis is tau, y-axis is x of tau, and x of tau is our unit step signal. Therefore, we are going to draw this unit step signal with amplitude 1 in this way. So now, on the same grounds, we are supposed to draw the second signal h of t minus tau. So here h of t minus tau, h is the function of tau. It is folded and shifted. So the original signal we are supposed to draw is h of tau. So we will draw h of tau signal. Similarly, h of tau is also our unit step signal. So it is with amplitude 1. This is our step number 1. In step 2, we need to have h of t minus tau signal. Therefore, here we have two operations. One is folding and second is shifting. So first we are going to find out the folded signal, which is h of minus tau. So h of minus tau signal will be folded along the y-axis. Therefore, we get this h of minus tau signal in the negative axis. Amplitude is 1. This will be your h of minus tau signal. We will just make one change. It is not correction, it is just a change. I will show h of tau signal with different color. So let's say I will show it with the pink color. Okay, just to differentiate x and h, I have just represented it in the other color. Now the step 3 is we have to shift this h of minus tau signal by t. So it becomes h of t minus tau, or just to understand, this minus tau signal is shifted by t amount. So it is h of minus tau plus t, which is nothing but h of t minus tau. So we have to obtain this signal. Now see how to obtain it. This is our tau. This signal is our h of t minus tau. Now I have this h of minus tau with me. I need to shift this signal by amount t. So here it is plus t. Therefore, this h of minus tau signal will be shifted towards left by amount t. Now whenever you are shifting this h of minus tau signal, you have to take care that you have to shift this signal towards entire left of x of tau signal. Our x of tau signal starts at origin, Therefore this h of minus tau signal needs to be shifted before the origin. So I will draw it before the origin as it is. The coordinate for this h of tau signal is starting at 0. Therefore I will mention it 0, and simply I will add the plus t parameter into it. So simply pick up this signal, h of minus tau signal, shift it towards left hand side. The shift will be before your x of tau signal, and place this signal over here. Whatever is the coordinate for h of minus tau, so h of minus tau starts at, the coordinate is at 0, so write it as it is and simply add plus t into it. This will give us h of t minus tau signal. Now the next step is step 4. So in this step we are going to draw both the signals on the same axis. So first we have x of tau signal with amplitude 1, and second we have h of t minus tau signal starting, the coordinate is at t. Both these signals have amplitude equal to 1. Now if we consider these two signals, now we are supposed to find out the integration in the sense convolution. So here we need to multiply both the signals. Now if I multiply these two signals, there is no overlapping part of this region, therefore the multiplication will not exist, means the answer will be 0. So this is our first condition, that there is no overlap, therefore our y of t, which is integration of x of tau and h of tau, so multiplication of x with h is 0, therefore our y of t will be 0. But for what condition this becomes, or for what condition this particular y of t will be 0? It is until this t is less than 0. Okay, so our first condition comes to be that if t is less than 0, there is no overlap and our y of t is 0. Now the next step is, so in this step 4 only, we are going to shift now this h of t minus tau signal step by step towards right hand side and check the overlapping region. So next I will draw the next shifted version of this signal, x of tau with amplitude 1 as it is. We are only going to shift this h of t minus tau signal. Initially we have considered that t is less than 0, there is no overlap. Now in the second case, the second condition, this t will become now greater than or equal to 0. If t becomes greater than or equal to 0, I need to draw this signal, this t point, somewhere beyond 0. Therefore this signal starts at t and approaches towards negative infinity. Both these signals will have amplitude 1. Now there is overlap of these two regions, or those two signals, and that overlap is shown with this region, which is from 0 to t. So here the overlap exists, therefore the multiplication in the integration x of tau into h of t minus tau will exist, and here we have the overlap and our y of t will exist for the integration. Now this integration will have the limits 0 to t. So these limits are for the shaded region where the overlap exists. So it is 0 to t, x of tau into h of t minus tau d tau. Now we are supposed to evaluate this integration to obtain value of y of t for this particular condition. Now the next task is this h of t minus tau signal needs to be shifted further in the right direction and check whether this 0 to t region changes. So here if you look at this x of tau signal, it is approaching towards positive infinity. If we look at this h of t minus tau signal, it is approaching towards negative infinity. And if we consider this point t, and if I shift this t point further by any amount, it will never cross this positive infinity. So our upper limit will always be t in this case. Similarly, h of t minus tau signal, this particular edge is approaching negative infinity, therefore it will never cross the origin. Hence the lower limit will also remain 0 in such case. Therefore there is no further condition where this overlapping region is going to change. If such condition exists, then we need to find out that particular condition of t and again integrate our overlapping region. So for this particular example, we have only two conditions. First condition is there is no overlap for t less than 0, and second condition is when t becomes greater than or equal to 0, the overlap exists and we need to find out the integration. So let us evaluate this integration. So our first condition is t less than 0, y of t is equal to 0. And the second condition is if t becomes greater than equal to 0, y of t is equal to integration 0 to t x of tau into h of t minus tau d tau. Now if we look at the values of x of tau and h of t minus tau, so here in this overlapping region, both these signals have amplitude equal to 1. X of tau is also 1 and h of t minus tau is also 1. Therefore, integration of 1 d tau is tau with the limits 0 to t, and if we apply the limits, so upper limit is t minus lower limit is 0, so our y of t is equal to t for t greater than or equal to 0. Now we will represent this y of t in a proper equation form. So here y of t is equal to, it exists for two conditions, t less than 0 and t greater than or equal to 0. For less than 0 it is 0 and for greater than or equal to 0 it is t. And if we draw this diagram, here it is now t, y axis represents y of t. So y of t is 0 for the negative axis. So for this region it is 0, and for positive region y of t equal to t, which resembles to the ramp signal r of t. Okay. Therefore we are going to draw y of t in this way. So this completes this particular numerical. So the summary of this convolution integral is that our input signal x of t was given, which was unit step signal. Impulse response was given, which is h of t. Again it was unit step signal. And now if we apply input to this system whose impulse response is h of t, if we apply input x of t or y of t, we get output y of t as ramp signal.